Okay, we're going to finish up 1.6, composite functions. And the central question for today is, how do I form, identify, and simplify a composite function? Before we start, I probably should give you the definition of a composite function. Okay, so now I'm going to have two functions. I'm going to put it in together, in the other, and it should come out with another function. Okay, so the first example is I'm going to let f of x be x minus 3 and g of x be 6 minus x squared. And I'm going to find the following. A, I'm going to find f of g of x. Okay, so if I look at this function, g of x is inside of f of x, which means I'm going to plug g of x in for the x value in, or for every x value of f of x. Okay, so if I do this correctly, I put this in for the x, because if it was f of 2, I would plug in the 2 for x. So it would be, instead of x, I'm going to have 6 minus x squared minus 3. Normally this would be x minus 3, but now I'm plugging in g of x for f of x, so this is f of g of x. And then if I simplify that further, it would be 3 minus x squared. Okay, for part B, let's flip it around. Let's find g. I'm going to write in another notation. G of f of x. So this time I'm plugging in f into g, and I got to plug it in for every x. So if I see, I'm going to plug in x minus 3 in for every x, since there's only that x squared, it's going to be 6 minus, and instead of x, it's going to be x minus 3 squared. Okay, and then I'll probably have to FOIL that out and simplify. So it'll be 6 minus x squared minus 6x plus 9 if I FOIL it out. And then if I simplify, it'll be negative x squared plus 6x. I distribute that negative, it'll be negative 9. 6 minus 9 is negative 3. Okay? Sometimes they'll also ask you for a value. So something like, let's change it up a little, f of 0. So trying to trick you a little bit. Okay, so now I'm going to plug, it's kind of hard to see sometimes, but I'm going to plug in f for f. Okay, so I'm going to write it out down here just to kind of see. So f of x is x minus 3, f of x, because I'm doing f of f, so I'm going to write out 2. I'm going to literally take this negative x minus 3, and I'm going to plug it in to f. Okay, so I should have x minus 3 minus 3. Normally this would be x, but now I'm going to plug it in. Okay, and since it's f of 0, I'm going to plug in 0 for x. So it'll be 0 minus 3, which is negative 6. Okay, so part D, last one. Let's do g of 1. Or another way to write that, let's see it in another form. It would be g of 1, same thing. Okay, so I'm going to take g, I'm going to plug it into g. So I'm going to take the 6 minus x squared, plug it into 6 minus x squared. So it would be 6 minus, and instead of x, it would be 6 minus x squared squared. Okay, now I'm going to plug in 1. So it'll be 6 minus 1 squared squared. 1 squared is 1. 6 minus 1 is 5. 5 squared is 25. So it'll be 6 minus, it'll be 6, no, it would be 25. And then it would be negative 19. Sorry. And then that should be it. Okay, so let's do another example. So this one we are going to identify the composite function. So we are going to write x plus 5 cubed over x as a composition of functions, meaning I'm going to break it up. Okay, so I'm going backwards in this case. This composite function, this is pretty much f of g of x. So I'm going to see this as f of g of x equals x plus 5 cubed over 6. So I need to figure out what g of x is. I need to figure out what I plugged in here to make this function. Well, if I look at this parentheses, it looks like, if I had to guess, I would assume this is what I plugged in. I plugged in x plus 5 for this function. So I would assume g of x is x plus 5, and I'll test it later. Now if I plugged in x plus 5 for x, so this would normally be x, so f of x would be x cubed over 6. Okay, so let's see if it works. If I did f of g of x, I would take this, I plug it in here. So does that look like that? Yep. So g of x is x plus 5, and f of x is x cubed over 6. If you have any questions, write it down, and we will answer it tomorrow.